Hello, everyone. I'm Fars from LightUp here on the marketing team, joined by Chad and Brian. If you guys would like to introduce yourselves.
Sure, I can go first. Hey, folks, I'm Chad. I was formerly the head of data products at a company called Convoy, based out in the Seattle area. It's a freight marketplace, very interesting data use cases. I've spent some time at Microsoft's artificial intelligence platform team. I've been in the big data industry about 10 years, and I'm here to talk to you about revenue generating data pipelines.
Yeah, hey
Thanks,
everyone,
Chad.
my name is Brian Filing. I head up field engineering here at LightUp. So I'll be kind of going back and forth with Chad a little bit near the end and how LightUp and data pipelines and data contracts and all that stuff works with data quality.
Thanks, Brian. So happy to have both you guys here. And thanks, Gabs. Thanks for saying we're very punctual. We're just thought we might come on live a couple minutes early to let folks jump on into the live stream here. We'll probably give a few more minutes to let the rest of the audience to jump on. But Gabs and other folks, let us know in the chat, where are you guys from? I'm dialing in from the East Coast here in the United States, in Boston, Massachusetts. Let us know where you guys are from in the chat. Chad, you're in the West Coast, right?
Mm-hmm. Yep. I'm in Washington.
In Washington. And then Brian, you're actually pretty close by to me at the moment, right?
Yeah, I'm in New Jersey right now. So
Yeah. There we go. How's New Jersey been treating you? Is it good down there? Is it too stormy? What kind of stormy?
no, it's cloudy right now, but it's not too bad. Not too cold. Chad, where are you in Washington actually?
So I don't know how familiar you are with the area, but I'm south of Seattle. It's around a town called Federal Way. It's like a smaller suburb. It's actually called Edgewood. Nobody
Yeah.
knows it.
I'm actually from Kirkland. So
Oh, you're from Kirkland. Oh, nice.
Yeah.
Okay, cool. I lived in Kirkland right before I moved here.
Nice. Yeah, I lived right next to, like probably 7 minutes away from the Microsoft headquarters in Redmond.
Oh, nice.
So,
Okay.
yeah.
Yeah, that's awesome. I was pretty close to the Kirkland downtown area, like the road that you take to go to downtown Kirkland. I was the road right next to that.
Nice. All right. Yeah, I know it well. We used to walk down there all the time.
Yeah.
So,
Looks like we have someone else from Texas here too. Someone from Houston. Shout outs to Carlos from Houston. We have Matteo from Italy. Wow, I wonder what time it is over there right now. We got some folks from San Francisco. Shout outs to Jamie from Denver, Colorado. We got John from Ireland. What's going on? Hope you're having a Guinness for me right now. Gabe from Los Angeles. What's up, Gabe? We got Diogo from Lisbon, Portugal. Ooh, I'm going to Portugal for a friend's wedding this year. I'm excited. I've never been, and I've heard so many good things about Portugal. We got a lot of people globally. I like this. There's some good global presence here. We got, hope I'm pronouncing this right, Ajay from Houston, Texas also. Nice to see you. Burke from Norway. And we have Janavi from Pittsburgh, Pennsylvania. Awesome. We'll give another minute or two for letting folks to come on air here. A couple dozen folks live with us right now. This is actually one of our first LinkedIn lives as a company at LightUp. We're hoping to do a ton more of these. And if this is the first event that you've heard about from us in general, we also have another one that we're doing with Fivetran and Elation and Coalesce in about a month. So stay tuned on our LinkedIn page and our email list if you're part of that to hear about more of the events that we're doing. So yeah. Oh, we have Dion from Brooklyn, New York. Tim from Texas. What's going on, guys? And Suraj from India. Hello. Okay, I think we have enough folks here, so we can probably pick it off and jump into the presentation here. So I'm going to go off stage as soon as I pass it over to Chad Chad is going to be covering the majority of this presentation, and then Brian will jump back in to kind of cover and add some input from his side, and I'll join around at the same time, and then we'll be doing a Q&A. So with that in mind, I'm going to pass it over to Chad. Feel free to start sharing your screen, and we'll get into it.
Excellent.
And one more thing, ask all the questions you want during the presentation. We'll have that dedicated Q&A at the end, and we'll have some people online from our side to also help and answer questions in the chat. But don't feel like you're interrupting at all. We will cover all your questions at the end. So.
Yes. Okay. All right. Well, let's get rocking and rolling here. So hope everybody is doing well. I saw a pretty international crowd, so thank you for taking the time out of your busy schedule to listen to me speak here. Should be a pretty interesting presentation. I normally like to work out what all my talks are going to be at the beginning of the year. So this is actually the first time I've done this one. So would love your feedback on how it goes. The main subject we're going to be talking about is revenue generating data assets and how to build production grade data pipelines. This is a theme I think you're all going to see come up more and more during this year, especially as the recession really starts to take hold, potentially more than it already has, is what does the data team need to do to actually prove business value in the eyes of the company? So let's just start going through this. So what we're covering today, like I said, it can be quite challenging for a data team to prove direct business ROI. I know when I was at Convoy, this was a conversation that I was asked many times, was to essentially justify the value of my existence. And the idea there is that at a certain scale, data teams are sort of stuck in this rut of playing analytics support to product teams and marketing teams. And as long as we're stuck in that support role, we will always be struggling to define our explicit business value. So the high level takeaways of like BI and analytics, it's amazing. It's a great starting point. Everybody needs it. But as the infrastructure starts to expand and the cost to maintain that infrastructure increases as well, then the use cases need to expand in order to justify that cost. The tooling and processes around these production grade use cases that are ROI positive is different than the tooling and processes and governance structures for analytics and BI. So there needs to be some mechanism of transitioning between these two worlds. And in some cases,
sorry to interrupt. I think actually we need to share the screen here. Okay, there we go. I think it is now there. Perfect. All right.
Okay. Oh, sorry.
Sorry to interrupt you. Yeah.
No problem. Okay, so I was just you got the general idea. So in general, where a lot of these the tooling around production grade data pipelines don't exist yet, or you have to string tools together. So we're going to be talking about exactly how you would do something like that. So the TLDR, if you're not familiar with Reddit lingo, this is too long, didn't read. So where are we right now as an industry? It's pretty hard to justify your business from an ROI perspective while simultaneously maintaining this very, very costly infrastructure and being incapable to tie it to direct business value. And when I say that, I don't mean, well, we generate important data for the company and everybody values it. I mean, the data that we are responsible for and the pipelines that we manage is directly responsible for contributing value to the business. What we need is a transition to data products. That doesn't mean we move away from analytics. It means we also start to embrace data products or data assets that deliver direct business value. How do we do that? Well, we need to think about a different sort of architecture. Data products require more of a software engineering workflow and best practices, things like CI/CD, and we'll talk about that during the talk, whereas just spinning up an analytics environment doesn't necessarily. The outcome of all this is that it is a production grade data pipeline, right? If you've invested in all of the pieces required to create, to support this production use case, then you have a production grade data pipeline. And some of those pieces include data contracts, a monitoring system, CI/CD, change management, all things that may sound very familiar if you're a software engineer or have ever worked in a software engineering workflow. Okay, so let's getting into it. I want to give you guys a little bit of context before we get into implementation details. So early on in the history of the company, most data teams are brought in to be support functions. If the product team or the growth team is attempting to measure the outcomes of their campaigns and features, then you really need a data team on standby to support you with that analysis. And in that world, the data is very valuable, meaning it certainly helps with decision making, but it's not critical in the sense of if those teams weren't there, the business falls over. Now, there's some pipelines where maybe that's not true, like our accounting pipelines, for example, but I actually put those into a different category, and we'll talk about that in a little bit. So in this world, data quality is very useful, but the direct ROI is quite low. And it's actually acceptable for the data to be directional. So meaning if the data is off by, let's say, 10% or 5% or even 20%, would that product or marketer have made a fundamentally different decision? If the answer is no, they would have made the same decision regardless of if the data was correct or not, at least to some degree of accuracy. Then we can argue that like data quality and directional data and accuracy in general is probably not that meaningful. The data team is usually pretty small, usually a team of 1 to 2. That means they have a tremendous amount on their plate. And there's not really a need to have a comprehensive data model at this stage because ideally most of your use cases are coming from 1 or 2 business units. So you might need to have a good definition of a customer, maybe of a purchase, of an item, right? These things might need to exist, but certainly not at the scale of an entire sort of enterprise data model. And the tools and processes for setting all these things up are scrappy, right? We're trying to move quickly, and that necessitates tools that are very easy to self-serve. And this actually maps to the maturity curve of the business itself, right? So when a business first starts, it's just trying to build the initial version of the product. If you don't have a product, you have nothing to sell. And in this world, data doesn't really serve any purpose because you're just trying to ship things. Now, once you've actually shipped something meaningful, you move to the acquisition stage. And at this point, you bring in marketing, you bring in sales, and you're really trying to prove out that people are going to buy it. This is where data starts to serve a support function, right? Is the marketing team doing a good job? Is the sales team doing a good job? How quickly is it growing? What sort of projections can we make, especially if we're thinking about fundraising and things like that? After that, okay, we've got customers. Now we need to retain those customers. We need to ensure that we have people coming back day after day, year after year. So we care a lot about, usage data. How is our product actually being leveraged? What's happening to churn? Are people leveraging the features that we're building? This is where you start to see a lot of product analytics become popular. A/B testing also becomes popular. But after we've basically ensured that we have customers. This is more or less product market fit, right? We found a product, we found customers, and they like what we've built. But then a change starts to happen. So we start to care about other things like the economics of the business and the economics of our sales, optimizing margin. Now, if you're optimizing economics, you cannot do that unless you have data. So this is a entirely different step in the maturity curve in the sense that it's not possible without data. It's not feasible. So data is actually the core of this sort of economic optimization. Same thing for the operational efficiency. You want to be able to operate the business at scale without going under. That requires collecting data on where are people spending the most time. How do you ensure that they're operating efficiently? Where can you add in automation into the company, et cetera, et cetera? This requires data. And then sort of the final step is, all right, we've got this big scalable business that can run well. How do we regulate it? You'll have auditing, there's PII requirements, there's governance, et cetera, et cetera. And at this stage, data is essential. There's no way around it. You must make an investment in data, right? So in the same way you've got this business maturity curve, you also have a maturity curve of the data itself. The data starts from sort of exploratory ad hoc development life cycles, and that's on the left side of the curve. And on the right side of the curve, you have really business critical use cases for data, AI and ML, financial reporting, really core objects and entities that thousands of people at the company are using. And we can't treat all of these data use cases as the same because they're not the same, and they have very different requirements, and those requirements manifest at different stages of the company's life cycle. So once you reach that end stage, right, the ideal perspective is you're starting to invest in data as part of the product. The data itself is making money. So you've got training pipelines for artificial intelligence, data mesh, reports, meaning data that is embedded in the applications themselves, auditing compliance like GDPR, ensuring that we're not fined millions of dollars, major entity models that everybody in the company is using, including software engineers in many cases, optimizing operational use cases like what is our call volume, what's our email volume, how many people should we hire or not, validation for labeling, actually selling the data as part of the service and like literally making money of it, and migrating between databases and doing refactors and things like that. So the point here is that operating a data infrastructure at scale is different from operating it in the beginning of a company's lifecycle. And at scale, it becomes a massive cost, right? Teams spend a lot of money on resources. They hire data engineers, they hire analysts, data scientists. You pay for Snowflake and Databricks and Fivetran and dbt and like all of these tools. And unless you're investing in use cases on the right side of that spectrum that I mentioned, then the ROI of this entire system becomes seriously questionable, right? Because you're spending potentially millions of dollars for something that's not actually making, any tangible money. And so this is usually the point where teams start to look around for meaningful use cases to make these investments, and they find themselves running into a brand new set of requirements where all that directional data that was okay before, well, that's actually not okay anymore. If we're in a compliant, if we're being audited, it's not okay to be directionally correct. We can't be off by 10%. That scrappy data model that we first invested in, it doesn't work anymore. It doesn't scale. The maintenance cost is massive, right? It's not just one or two data engineers or an analyst. It's a fleet of these people, and oftentimes they're significantly understaffed as it is. The data quality is a necessity. And if something breaks down, then the business, even incrementally, it starts to suffer. So the high-level summary, and this is just a mental model for how we think about these problems and the evolution of data of a company, is you've got data as a support system and you've got data as a product. So data as support, primarily BI and analytics, super early, super important early on, where we're just trying to understand how the business works. It helps like justify, the product team and marketing team spending on things. It has to be fast. Directionality is okay. It doesn't require a massive amount of complexity. Ideally, it's inexpensive. Early on, it's inexpensive, but that does not, it does scale to being quite costly. And but it's also really challenging to justify the massive support cost it takes to maintain it. Data as a product, we're mainly talking about things that are making money. AI ML is an example. This becomes much more important later on, unless your business is, providing some ML centric product, which Convoy was. These things can generate ROI all by themselves. They're not support systems. They have to be built from day one for durability and scale, like any other part of the product. Directionality is not something that is acceptable. It requires complexity. It's expensive, but you can also measure the value quite directly, and it is much easier to justify if the initiatives actually work. Okay, so let's talk about the modern data stack. Hopefully everybody on the call is familiar with the modern data stack. These are the tools that exist in the context of the cloud that we use to ideally quickly spin up your more modern data environments. You've got transformation tools and dbt, orchestration, tools for a BI and analytics. There's ELT tools and ETL tools. And the whole sort of theme of the modern data stack is move fast, onboard fast, right? And so this is great. It's great if you want to get started quickly as an early stage company, but it is very, very challenging to scale this to many or even one production grade use case. And I can say that because at Convoy, we implemented this exact stack. We did this about 4 years ago when a lot of these technologies were very new. And we scaled to a point where this system did not work for us anymore. And many companies are now beginning to experience something similar, or it's in their direct horizon. So the pros of this, of the modern data stack is, number one, they are self-service. It is a self-service system. It's pretty simple to learn. It's SQL, it's Python. A lot of it is managed. It's sort of plug and play. Implementation super simple. The cost doesn't really begin to accumulate until later when you have big volumes of data or very, very complex data models, and it lets teams move fast. On the cons, you don't really have great ownership the same way that we think about service ownership, right? So if you're building a product, the engineers who created that product obviously take ownership over it. But in this world, there's not this clear distinction about who exactly owns the data. Is it the person producing the data? Is it the person who's downstream that's transforming it? Is it the data engineer that's implementing the tools? It's not really clear. So you run into this garbage in, garbage out problem where a lot of the data, because we're just piping it into transactional systems, we're not thinking super deeply upstream about how that data needs to be used. That means things can change at any time. That lack of ownership eventually results in tech debt, right? Spaghetti SQL, it begins to pile up in the warehouse or wherever you're doing your transformations. Teams are writing their own queries. They're not really trusting other people's. It becomes really hard to figure out what means what. There's not that much documentation. And in general, the data quality kind of starts to fall over. This is the inevitable the inevitable result that I've observed for the modern data stack time after time after time after time with almost hundreds of folks I've talked to at this point. So there is a cost of moving fast, right? The benefit is very clear. You can answer a question really rapidly. The problem is when you're just doing this sort of plug and play, I want to pull some data from a transactional system or pull it from an API, or maybe I pull it from a third-party tool. I do some really quick manipulation and I throw it into a dashboard. I've essentially created what I call like a non-consensual API, meaning that the producer of the data never actually agreed to vend data in the format that I've expected for my use case. So they have no accountability to SLAs. They have no accountability to how the data changes over time. And because I don't have that guarantee, I have to build in a lot of filters, a lot of testing. I have to manage this entire system myself. And fundamentally, once bad data actually filters into the pipeline, it starts to break down. So this is sort of the classic setup for data consumption in most companies, where you've got some operational use case, right? You have an app, and that app is producing data when a customer logs in. We store all of that in a database that's owned by some backend developer, and the data person, whether it's a data engineer or could be a data scientist, recognizes that data is very, very meaningful for the use cases that they have. So they might go out, say like, hey, can I get access to this? Maybe I'll get Fivetran or some other tool, plug it into my database and extract it out on a cadence. And now you've sort of introduced this non-consensual API. And when things break, nobody is really accountable for it, and that causes all types of issues downstream. Okay, so what do we need in order to fix this world? How do we transition from this lack of ownership, lack of great engineering practices, to one where we can support these production grade data use cases at a meaningful scale? The first thing that we need is APIs, right? And that means inputs, outputs that are all written in a common language around the data itself, the schema, the semantics, and other means of validation. There needs to be some sort of agreement between the owner of the service and the consumer, and manifested as a contract that this is the data that I expect, this is what it should look like. And if something breaks, there's some accountability to take ownership over it and fix it. We need SLAs, we need ownership, governance, and documentation. It's just an API, right? We just need APIs for our data. We also need really good change management. So CI/CD, version control, change communication, alerting, unit testing, integration testing, right? All of these, the very common engineering systems that we have elsewhere in our product, we need that for data too. It seems self-evident, but a lot of companies do not have this. And we also need monitoring, another thing that software engineers are using all the time. What sort of contracts are being violated? How are they being violated? When did those violations happen? And doing some root cause analysis to figure out what was the sort of the primary issue that potentially caused a major downstream change. So this is what I'm referring to as data as a product. right? We're thinking of data as an output of an engineering system rather than just a simple set of aggregations that's owned by a data team. So the ownership of data and data quality has to shift left if the data is valuable enough that it needs to be treated in this way. So like I said, API generation, CI/CD monitoring, all very, very critical. The downstream data team cannot possibly own data quality all by themselves. They may be able to take accountability for a piece of it. They certainly need to ensure that the data which is expected matches to their expectations, but they can't be responsible for generating the right data at the source. You also need decentralization. If you try to do all of this through a single bottleneck, one team that's attempting to wrangle every engineering team, you might be able to get away with that at a small company for a while. But once you start to scale, engineers, I'm sorry to say, just get hired way more frequently than data people. You have a relatively small data team, massive engineering team building product. So trying to centralize, it just doesn't work. It's slow. It creates a bottleneck, and nobody wants to adhere to that bottleneck. There's lots of good standards for this that already exist, and we should, just follow those. And you need to have a very clear ownership at every handoff point. This is basically just an API, but in data, it's a little bit different because we don't just have APIs, handoff points from one service to another service. We have handoff points from services to downstream data consumers, like the data warehouse. And then there's also handoffs from like tables within a data warehouse to another table. So data products, and this is a really important point, data products are a subset of all data. So not everything needs to be treated as a product. Only the things that are most critical, most important, and generating business value need to be treated as a product, because as you can see, there is an additional cost to creating and maintaining a system like this. So there's this whole thing that we've been talking about, the CI/CD, the APIs, et cetera, this is what I refer to as the production grade data pipeline, and is implementing these three systems effectively and uniting the data producer and the data consumer in a single sort of production development workflow. Number one is the data contract. So this is the API built for data, schema, semantics, the governance policies, and a mechanism of enforcement. Then you have a surface for data management. So that includes the actual enforcement mechanism, the vehicles for CI/CD testing and documentation, and then you have monitoring. So this is where, sure, we're not going to be able to catch everything in the CI/CD layer. There's some changes to the data that are very important to us that we can only detect once regressions have actually been introduced. But we want to try to detect those regressions as early as we possibly can at every handoff point that we possibly can, and then push that back out to the producer to fix. So you saw that diagram before of the non-consensual APIs. On the right, I am presenting, what I think the world must look like in order to support these high-value data products. You have the database and a contract between that database and, either your data lake or your data warehouse or just some tables. Then there's a set of expectations on the data that we expect to receive, and there are checks that run that ensure only good data is making its way into our pipeline. And then there's another contract between the table that is aggregating the data and then the actual data product. So the thing that is generating all the value for the company. In the example here, it's a training set for a machine learning model, and there must be a expectation on that as well. Okay, so what are data contracts? I've kind of already highlighted this, but let's just be a little bit more explicit. Data contracts are API-based agreements between producers and consumers, which capture schema, semantics, distributions, and enforcement policies. So hopefully this answers a question that you might have had, which is like, how is this different from APIs? Well, it is an API, but when we're talking about data, it's more than the way software engineers traditionally think about APIs, right? So it's schema and semantics together. There needs to be some mechanism of enforcement on the data. We can't just have a written agreement. I mean, you can. That might not be a bad start just to establish the culture, but it's going to be really, really difficult for you to have this system adopted at scale unless there's some type of a programmatic enforcement. there needs to be a single surface where all this collaboration can happen and people speak the same language. This has traditionally been a big problem at these businesses where software engineers are essentially speaking one language, like they are thinking about their work, and data people are thinking about their work. And sometimes they get angry at each other and they're not really talking in a productive way. So there needs to be a single surface where all this conversation can happen. It should happen in an agile environment. And it should be about placing data governance incrementally where it's needed, right? We don't need data governance on every single piece of data in our data warehouse. That would be crazy. And this is one of the big reasons that a lot of data governance initiatives fail, is because they try to tackle governance everywhere all at once. You actually only need data governance on a few places that are really meaningful. So what does a data contract look like? Here's a pretty general idea. So on the left is everything that I said, schema, semantics, SLAs. And then there's a set of validations that runs as the data is moving from one location to another, checks on the schema, checks on values, checks on cardinality, distributions, and so on and so forth. So where do you actually begin rolling out contracts? I've mentioned this already, but you really want to think about implementing data contracts at each handoff point of data. So if a data is moving from one system to another system, and those systems are owned by two totally different people, I think a data contract is necessary if you're trying to serve a production grade use case. This ensures that the pipelines don't fail anywhere. I think that a great starting point is usually as upstream as you possibly can. And we'll cover this a little bit more in a bit, but it's really hard to implement contracts starting from the middle, because the team that you're asking to put the contract on could potentially be broken by someone else. And that means they're going to be accountable to, a data failure that wasn't their responsibility. So talking about sort of streaming and batch, my perspective is it should be implemented everywhere, right? It should be sort of in the production code base, in CI/CD. It should be for streaming architectures, if that exists at the company, and it should be for batch systems as well. So CI/CD, the purpose there is stop the bad data before it makes it in. For streaming, we want to detect row level changes, right? The more incremental that we can possibly be, we can ensure that there's not costly processes for the data consumers down the line, like running backfills and things like that. And then for batch, we're trying to detect violations that can only be detected in aggregate, like we're seeing data drift off some median by X%, or the distribution of the data should be normal and it's actually bimodal, right? Like those are examples. So I see data quality in general, and specifically the value of contracts, like really summed up with these 2 points, which is a mechanism for prevention and a mechanism for detection, right? So it's kind of a summary of what we just talked about. On the prevention side, there's a few things that we can do with contracts. Number one, they get inserted into the CI/CD workflow. We have the schema that gets defined in a registry. At Convoy, we use the Kafka schema registry to store and define our schema. And then during the build phase, if the schema is being updated, we run backwards incompatibility checks. And if those backwards incompatibility checks fail, then we will break the build and alert the owner, alert the software engineer that there is a contract in place and they need to go have a conversation with whoever is downstream of them. You can think of this as, unit testing, integration testing. This is kind of the general theme of getting upstream as much as you possibly can. The other thing that's really critical to do in the prevention stage is to help the producer team understand what is the data they own, how is the data that they own actually being used, what is going to happen if they make this change. Most software engineers don't have this today, right? They're just kind of doing things blind, and then people are yelling at them later. So if they had a tool set, like data lineage is something that's really popular. We use this at Convoy, doing data diffs so that you could potentially run some test data through a pipeline, or have run almost like a feature flag and not surface some new data out to the company, just validate whether or not it meets expectations and meets the contract after a change. All of these things are incredibly helpful on the prevention side. On the detection side, we want to be really good at monitoring in a variety of different places, of defining a wide variety of constraints and potential business logic, and then of doing something with the data if it's not that great. So if the contract is violated, and we don't want it to enter the pipeline, okay, maybe we shift that off to a dead letter queue. We alert an engineering team so that they can go and take action and treat it as any other regression. All right, so when we think about the architecture of a system for prevention, this is what's in my mind, and I think it's what's in most people's minds when we talk about data contracts. There's really 3 primary pieces to this. We've got the CI/CD process where during the build phase and the test phase, there is a contract definition that is stored somewhere at Kafka. At Convoy, like I said, we store it in the Kafka schema registry. So there are these schema compatibility checks that run during CI/CD. We also run a check. We basically use Docker to spin up a copy of the database and then run a backwards incompatibility check on that as well. And if all of that checks out, awesome, then we can actually publish the new schema and everybody gets a thumbs up. So I recommend using a schema, some like well-known schema serialization framework for this. Protobufs are really great. Avro is really great. Even JSON is totally fine. It's nice. Of course, it's preferable to be strictly typed, but this is the system that I think is most ideal for a CI/CD based prevention framework. Next, you've got detection. And then in a detection system, there's a bunch of different types of checks that you could run. I haven't even included all of them here, but I just wanted to dive into some somewhat briefly. So first, there's checks on schemas and values. Schemas, depending on where you are, schemas can either change all the time or they could barely change at all. But it's still critical as a foundational part of the contract. So you need to ensure that the schema, matches the contract, that major columns are not being dropped, that the names of the columns are staying the same. This is really critical. You also need to ensure that there's things like if there are null value checks in place, that those null value checks are actually working as expected. You may have uniqueness checks that you want to put in place as well. Or you might want to look at the values. Well, this is sort of null values, but you may want to expand your constraints to more values. So if I have a ID field that needs to be, that's always going to be 10 characters long, I need to define that as a constraint. And if it's not 10 characters long, it means there's a bug in the system or somebody made a mistake with like manual data entry, and they should not be allowed to do that. On the semantic side, this is more about sort of ensuring that the IDs of our core entities match the corresponding values in the source tables, and then looking at the relationships between different objects. So if I have an object called shipments and an object called shippers, how do these things interface with each other? And I need to define that relationship. I can define cardinality. This should have a one-to-one. A shipment and a shipper should have a one-to-one relationship or one-to-many relationship. And as the data flows through the system, is that actually the case? Or do we see scenarios where we have 2 contracts for a single shipper? Well, that doesn't make sense. That's probably a bug. Then there's other things here that we could talk about as well. Like I said, there's a long tail of these things, but one other thing that we did at Convoy was we defined the semantic meaning of a column. So if you have a column, let's say it's called, shipment distance in miles, there is a semantic meaning of that where it's the distance between the starting destination facility and the ending destination, the starting facility and the destination facility expressed as miles. And so if we detect that some engineer is going to be changing that column, we could just pop like a qualitative alert that says, hey, there's a contract on this column. Here's what this column means. Does it still mean that? Those are the types of awareness mechanisms that work really well in preventing data from breaking in the first place. And then lastly, you have distributions and SLAs. So like I mentioned before, is this a norm? Should this be a normal distribution? And if it's not, does it indicate something fundamentally wrong about our implementation? And freshness checks as well. So you can have a last updated column, and then you can detect if that last updated column is at the date that it ideally should be for the data. So let's talk a little bit about like streaming versus batch. Like I mentioned before, I think that you need to have both of these systems. Ideally, If you don't have a streaming system, obviously you can't have streaming data contracts, but ideally you should have both. The great thing about streaming is that all the checks are pushed upstream. The data is enforced before any of the problem happens. You get very, very tactile feedback. So, in real time, when something goes wrong, the engineer gets an alert and can fix it. And the goal is you can shift that data somewhere else, and you can check it at the role level. The con is it's expensive. You have to have a streaming infrastructure already, and you have to tie a bunch of tools together for stuff like this. On batch, it's way easier to get started because you don't need to have all this really complicated infrastructure. Usually the data engineering teams you don't have to go and reach out to a software engineer and try to get them to take accountability of something. You can basically just start working on, consumer to consumer contracts between one table and another table. And like these types of checks are always needed. Like they must happen at some point. It's just a kind of a question of ordering. The challenge with batch is that obviously the detection times are a lot longer, and that means the tactile feedback isn't as good. And if something does go wrong, then you have to, roll back the change in the warehouse to a previous version. And you potentially will have to backfill the data. And of course, doing root causing is very challenging if you don't get the row by row values. So core components of the data contract, number one, you store it. You store the schema in some registry. It could be the Kafka schema registry. It could be GitHub. For streaming systems, then you have a set of semantic monitors that get defined somewhere. This is what we did. You can run the set of checks in a stream processing layer. Flink works. KSQL works. It's fine. For batch, you would define your monitoring system in some tool like LightUp. That can effectively monitor the data warehouse with a variety of checks. And then if the contract is violated, then you can roll it back to a previous version using something like dbt. And then you have a catalog, right? So a catalog of all the contracts that exist and who owns them, what is all the semantics. And ideally, none of this stuff has to be defined after the fact. It's all defined, when the contract is created, and then those semantics filter downstream. So this is a really important concept to be aware of when we're talking about contracts. Like, don't try to do everything all at once. This is a big change for a lot of businesses. And I know sometimes I'll talk about these things and I get one of two reactions. Either this is awesome, we need to do this right now, or there's no way that this could possibly work. This seems like an utopian vision. What I can tell you is that it does work. We did this at Convoy. There's an entire platform at Zillow that does this and facilitates these changes. I think Shopify and Spotify both have a platform like this. And there's a bunch of companies that I've spoken to that are all actively building out their own data contract platforms right now and understand the need of them. But it is a maturity curve, and you have to graduate up from one step to another step. You can't throw everything all at once at the engineering team and say, I need you to own all aspects of the data right now. So what I found works really, really well is starting with awareness. So that's going to the upstream owners of the data and just explaining, ideally programmatically, this is how the data is used. This is sort of the important, tier one data products that are consuming this. This is what happens if you send over bad data. This is how it impacts the company. And this sort of facilitates ownership. And the easier that you can make this, the better. So this is why I strongly recommend something like Data Lineage. If you're using Snowflake, they have a native column level lineage tool that you can use for something like this. It works great. On the ownership side, this is like the actual definition of the contract, irrespective of the constraints that come along with it. So starting just with schema ownership is really easy. It doesn't require a significant deviation from what most software engineers are already doing. And if you can inject yourself during the developer workflow using tools like GitHub, even the tools are exactly the same. Next is the API itself. And this is starting to think about, what is the actual data that we are emitting? How do we ensure that the inputs and outputs are as we expect? How do we have good documentation, versioning, et cetera? And then finally, at the most sort of advanced end, you've got the constraints and the rules. And you should really only start rolling out ownership of more complicated constraints once you've established that great relationship between producers and consumers. So where do you start with data contracts, and how do you start? So again, this is what we specified at the top of the hour. But contracts are essential for the production grade data pipelines, but not necessary for all data. So if you approach it from the sense of, I need contracts everywhere in my data ecosystem, you will fail. And you will fail because A, that's a ton of work, and B, a lot of engineers are going to question that, right? Why is it useful for me to change my workflows and start to think more critically about the data if I don't even know how the data is being used, and if the data is not even being used in some valuable revenue generating mechanism? So my sort of rule of thumb is if incremental data quality does not result in incremental business value, it's probably not a good place to start. The flow I do recommend is find an ROI generating use case. If you're a data engineering team, usually there's some data scientist or product manager or analyst or business owner that like really is complaining about the data quality a lot. They're significantly affected by it. And it's great to partner with someone like that to have them be a sponsor. Understand the impact that poor data actually has on revenue, on the business. Implement contracts throughout the pipeline, ideally starting as upstream as you can, and then demonstrate that the increase in the robustness of this new model translates to business value. So I'll talk about a use case in just a second. Then you want to roll out everywhere, right? So the way that we did this at Convoy is like we rolled out hundreds of data contracts, and we could prove business value. One really meaningful example is that we had a pricing model. That pricing model was core to operations at Convoy. We were getting a lot of nulls, a lot of data that we had to throw out of that pricing model because of upstream issues. And it was costing us lots of money, hundreds of thousands of dollars a month to millions of dollars a month in regressions. And through contracts, we were able to substantially reduce that number. And we could point out, hey, here's how much we're saving now. The big change that happened was that data teams and engineering teams actually began talking to each other about these issues, and not in an argumentative way, in a, hey, what do you need? How can I help you type of way. We also got way, way better data documentation because, again, we're pushing it upstream and then it trickles down, very clear ownership. And then there's a lot for us that's sort of remaining, but there's many different types of monitors and obviously more contracts we want to roll out. So last slide here. The really key takeaways of the entire presentation is once a data team reaches scale, there is a huge amount of value in the data team beginning to focus on ROI generating data products. That requires an infrastructure that is designed to scale and has data quality at its heart. That may not be the infrastructure that exists. Production grade data pipelines and data contracts in particular facilitate this transition. So yeah, there's a lot of other sort of points I mentioned down below, but that's the core. The most important thing I really want you to take away from this is that, like, you know, start with the high value use cases. Start with the use cases that make the company money. Don't overinvest. Prove out the business value. And what you will see and what we saw at Convoy is that the producers are then excited to take this role on. And in a lot of cases, the engineers were the ones coming to the data team saying, hey, what kind of contracts can we take for you? Because they understood now how the data fits into the sort of their actual job function. And it was simple for them to do. So that's it. That's my end of the presentation. Thank you so much for the time. I know it was long. If you want to come and talk more about data contracts, we have a whole community for this, dataquality.camp/Slack. It'll redirect you there. It's totally free. It takes 5 seconds to join. And if you want to talk to me personally, you can always reach out on LinkedIn. And that's it. I'm done. Brian?
Perfect. Thanks, Chad. Appreciate that. Let me see if I can share my screen real quick. Awesome. All right. So let's talk through data quality and data contracts, right? So we want to carry this on. There's actually quite a few comments in the thread here that are talking about like how are contracts enforced, how is ROI associated contracts, tech debt associated contracts. And this is actually something that we can talk about in relation to data quality as well, right? Because there's two elements of data contracts that are going to be severely impacting your business. One is going to be the data that's coming in and what's going to be after the data contract is initially implemented, right? So someone actually mentioned in here, like, what do you do with data that is being ad hoc queried at the end, or data that's being transformed after a contract is done? And that's really kind of the correlation there that we're going to see. So the first one is when you have data that is exploding in size and complexity, and in this case, you're going from tens of tables to thousands of tables. You're going from, maybe couple hundred columns, maybe a couple thousand columns across these tables. Now we've got millions of columns. We've got wide tables. We've got deep tables. And now we're really quickly scaling up and jumping into petabytes of storage, high 100 terabytes of storage. So those things are actually driving a lot of complexity, because now if you want to enforce contracts, you have to enforce contracts backwards, right? You have to do it based off of where it is now. And then trying to do that when you have these really wide tables, these really deep tables, it does take a lot of administrative requirement. As Chad said, sometimes if you try to boil the entire ocean, it's not going to really play out super well. So you want to kind of incrementally lead in to what that's actually implementation is going to look like for you. Make sure you get someone who's going to sponsor you internally, like an executive, a VP, someone who is bought in with the outcome for the business, and then bring them in alongside you so that they can help you kind of push this through and make sure that it's actually being sponsored, and you have some backing internally about that. Now, one of the big issues is actually understanding the data is really hard. You need to make sure you have subject matter experts around every data set that's coming in. If it's streaming, if it's batch, how is it streaming? How is it batch? How old is the system? Is it are we talking mainframes? Are we doing something more around like an OLAP system? So those are all the complexity portions of things, and understanding that actual data can be extremely difficult. There's a ton other requirements in the data world that will actually scale that complexity out. So you have scalability issues significantly. There's also user experience, right? In some cases, the people that know what they're doing with the data don't know how to correlate that programmatically. And the people that know how to do things programmatically with the data don't necessarily know how to converse with like a business-oriented team, right? So sometimes you have really technical analytical people, and sometimes you have analytical people who know how to navigate an Excel doc or know how to navigate a Power BI scenario, right? So how does the user experience, how is that implemented by data contracts or data quality processes, especially in correlation to those? Metadata checks, they just don't work. So you can have a metadata check in the sense that schema must be adhered to, but how do we enforce a data contract that says not only must this be a numerical column, but every field that comes in needs to be able to be within this range, or it can't be null, or it has to be less than X, right? It gets significantly more difficult when we're doing things like, every single cell in this column that's a contract-oriented column, that has to include certain characters, right? And so enforcing not only the fact that your schema, your metadata is actually meeting the requirements, but also that the data that's actually coming in, making sure that that meets the requirements that are required, and then move that to a dead letter queue like Chad was talking about, or be alerted to the fact that it's there so you can go in and do some form of master data management change inside. And then lastly, there's just difficulties in integrations, right? Like in some cases you have a schema registry. So Kafka has a really good schema registry. Confluent as a result have a good schema registry. You'll have built-in schema registries with like relational database systems where it'll just reject your data entirely if you try to insert something that doesn't exist. But other systems just don't have or just don't have good integration points. It's really difficult to integrate. So how do you bring that in? You have to put in a broker, an intermediary before you get the data to actually load through that system. That's in and of itself going to be difficult. And then lastly, what do you do with all the data that currently exists? For those of you who are wanting to start your business right now and you're going to bring in data right now, implementing data contracts at the get-go is going to be super simple. But what do we do with the petabytes of data that already exists for us, right? So what we need to do is actually kind of implement this data quality concept as to enforce data contracts, but also kind of like backfill or back test those data contract sets, right? And so I know Chad had mentioned things like distribution checks and making sure that that fits requirements, conformities, and making sure values are actually accurate. Here's another one that a lot of companies are dealing with. So those of you who are listening on this stream, if you're dealing with any company that is highly regulated or you have a lot of compliance requirements, it's not as easy as saying, does first name only contain non-strange characters, right? If it's an email, does it actually match the email requirement? Yes, that's needed. But in a lot of cases, we're talking about cross-column correlations. Well, if this table is of this value, then another table completely separate from this one must have an associated ID to that, because we're going to be regulated on that. It has to do with how we're talking with our customers, but also how we're talking with the government, right? So you can have some pretty massive requirements there, and enforcing that is not simple, but making sure you're being alerted to that can be a lot easier than expected. So that's the data quality data contract set. And honestly, like if you've been in this space for a while, you've seen this constant revolution of how everything is just almost recursive, right? Your data model evolves in some way, and then you find out you don't have enough coverage for that data model that just evolved. So now that moves into the fact that you've missed a bunch of issues with that data. So now you're reactively building out these data quality checks, or you're reactively building out data contracts, right? If you get like a brand new data set, and then all of a sudden that moves back into data model evolution. And then you just keep repeating that over and over and over again. So this is a very common thing. I'm sure all of you have dealt with data are actually experiencing this right now. So let's talk about who is LightUp and why would you use LightUp, especially in regards to your data quality, your data contracts. So LightUp at a high level is data quality for the enterprise at cloud scale. We're very specific about that. We want to be the best in data quality that's out there. We want to be doing that for the enterprise. And when we say enterprise, we mean the complexity that comes with the enterprise. And we want to do that at scale of petabytes and hundreds of terabytes and be able to scale well without having issues. And the reason why we're doing this is because not only enterprises, but really every company nowadays is driving all of their customer experience through that data set. So every single piece of data that's coming in is actually reinforcing, you're enhancing it, and you're actually driving your customer experience as a result. Now, that customer experience in the current economy is to keep the current customers you have and avoid the churn of the customers that you have. When you have a different economy, you might be associating customer experience with like revenue generation steps and how do we actually improve and maybe even add new functionality. Now, everyone in general is not only driving customer experience through data, but they're also making massive investments in the cloud. That used to mean you're just dumping a lot of data in a data warehouse, but that also nowadays it means we're implementing streaming technologies that are cloud oriented like Kinesis or Kafka. That means we're implementing microservices in some ways. We're working with Kubernetes or ECS or something like that. And that also means that now we're looking at OLAP features like Elasticsearch or OpenSearch or Rockset or something along those lines. And so what you need is something that is going to be able to understand your data across all of that, but at a depth that you need for your business, right? And so as a result of that, you need data contracts that are going to be very beneficial for you. And you need something that's going to validate that data contract out of the box. So you want to make sure that if things get through, does it actually match the data contract requirement? And then also, what do you do with all of your historical data that's there? And then lastly, what do you do with all of the data that's post your data contract? Making sure that your ad hoc sets, making sure that you have your post-transformation checks, reconciliation between two tables. We want to ensure that that actually happens. And that's something that LightUp actually has out of the box. And then lastly, there's the data quality coverage. It just covers everything. With LightUp, we can do across all your data warehouses, your data lakes, and all your databases. So you're not limited to cloud-only based technology or cloud-first technology, but we can also understand your data and the depth of data and how your data contracts are operating. And we can understand that even like your Oracle systems and your Microsoft SQL systems and your Postgres, things that actually live usually on-prem, right? The last things that move up to the cloud in this sense. So the next question is like, why would you use LightUp? So that's who LightUp is. So why would you use LightUp? So the first reason why you would actually use LightUp is we understand your data in depth. So we're not just saying, well, how many null percent do you have in this column? What's your typical range of numbers inside this column? Those are relatively easy, right? Min, max, average, quartiles. It's relatively simple stuff that you still need, but it's really easy to understand. But really what you want to understand is the depth of your data. So if I have certain values that are outside of a range, well, who's that really affecting? If I have clients, which client is actually being affected by that range being out of expectation, right? So that's going to be your deep data check. The next one is the fact that we could deploy anywhere. So you can deploy LightUp inside of your own cloud and your own VPC. You could use a SaaS version of LightUp. You could put it 100% behind your network if you want to. So we deploy anywhere that's needed for your security team, whatever works best for your InfoSec requirements. We can absolutely deploy there as needed. Everything inside of LightUp is actually very quick and easy to use. So we have automated metrics out of the box. You can just turn them on and go. We also have low-code metrics. For those of you who either are or have people who are not really like accustomed to SQL or need complex checks in some way, complex data quality understandings, in a way where SQL might be a good way to represent it, but you don't know how to write it in SQL. In LightUp, we actually have a really great drag and drop feature. You can literally just drop down exactly as you would expect to navigate how you would set up an Excel doc or a CSV file, right? And then the other thing is that the scale is just massive. So the way that we do this is, instead of Light Up pulling your data out and analyzing it, we're actually pushing queries down into the data sources themselves. And the result of that is that we have very fast, very optimized queries. It's super beneficial for you. It scales massively as a result. We've got customers that have tens of thousands of stores or sites globally, and they're actually able to run data quality checks in essentially real time across all of those stores as needed. So those are the different, like, who is Light Up, the different why is Light Up. I really appreciate everyone jumping on this one. I know Farah said that we'll be staying on for another 15-30 minutes to answer any questions. So that's pretty much everything for me. But if anyone wants to ask any questions, let's get in touch. Go ahead and hit that QR code and grab that, and we can talk a little bit more about data quality, data contracts, how Light Up can actually benefit your business.
Thank you so much, Brian. That was great. Yeah, as Brian mentioned, I mean, if you want to get in touch with our team, we have data quality experts on hand, including Brian himself. So click that link in the chat or scan that QR code to get in touch with us. And with that, we have a bunch of questions from the chat window. So we're going to stay on for another 15 to 30 minutes to answer your questions and have a conversation with you all. That's what you guys are here for. It's what live events are all about. It's about the community. It's about us being able to talk to you directly. So to kick things off, Anubhav, I hope I pronounced your name correctly, says, and I'll show the question here on screen, even if we follow the production grade pipeline, which adheres to a software engineering model, post-enforcement of data contracts, and even after unit testing with great expectations once data reaches the warehouse, there would still be ad hoc use cases for analytics and BI if we have to serve the business. Does that violate the data contracts created upstream? And if so, how do we cater to analytics use cases?
Yeah, so I can answer this one. Well, actually, is it just us? Is Brian still on? I can't see.
Yes,
oh, yeah.
Brian.
Yeah,
okay.
I'm still here.
Sorry, he was hidden by some things in the chat there. Yeah, so the way that I like to think about it, I sort of laid it out a bit in a slide earlier, but I imagine a spectrum where on one side of that spectrum is sort of analytics and ad hoc use cases, and the other side is sort of production grade stuff. And I sort of label those spectrums, the two sides of the spectrum are production on one side and prototyping on the other side. So the ideal workflow, and this is something that we were rolling out at Convoy and it seemed to work pretty well, is that if you are in a prototyping environment, so it's fine to just do replications of your database into the warehouse. It's fine not to have data quality in some or a lot of places. That's totally okay, as long as you acknowledge that the data has a potential of being wrong, and potentially wrong by a significant amount. If the data needs to be under contract, the way it should work is some data professional, some data developer should iterate over the data, refine it repeatedly, test it out, similar to any other MVP or product, deploy it into a production system, which could be just like a Tableau dashboard, validate that it actually adds a significant amount of business value, and then, and only then, it is transferred to be part of the production grade data pipeline. The problem is we want to keep the sort of experimental and ad hoc explorative use cases totally separate from the use cases that we can very clearly tie to business value and we can make a strong business case for. In fact, before I was in data, I used to be a designer. So I was a logo designer. And this is extremely familiar, extremely similar to the process that exists in design, right? When you're designing, you iterate a bunch first. You take out your pencil, you draw various different versions of the logo. You might refine one, change one, update it, and then you iterate on it, iterate on it, iterate on it. And then once you're actually ready, then you will deploy it with all of the branding, packaging, fully vectorized, and the customer will pay for it. I think that is the workflow that needs to exist for these production grade data pipelines, essentially starting from prototyping and then gradually moving to something that's more well supported.
Thanks, Chad.
Yeah, just to backpack off of that, the other thing to keep in mind is there's an element of ad hoc querying or analytical querying that is based off of the data that exists. And if you enforce data contracts, you're enforcing the structure and the model set of the data and how the data is coming in and being shared to make sure that it doesn't break things downstream. Right now, The thing that data contract won't help you with is things like, what if I have anomalous data sets that are coming in the sense that something is outside of a designated range, right? That's something that you could probably implement in a contract in some way, but if it's real data, you want to be alerted to the fact that you're really having an anomaly, and that's something that you actually want to do in monitoring side of things as well. So that's why you would pair a data contract as kind of like your enforcement gate to make sure that bad things don't happen as it's coming in. But then you also want to make sure that you're pairing that with monitoring so that you can be alerted to when bad things come in. It's not because they weren't enforced, it's because it's actually something in the data itself, and you probably should be alerted to that, right? So think click streams, think ads, think revenue that's being generated. Think the row count that's coming in, right? Row count is not necessarily a contractual requirement that you can enforce, but you want to be alerted to the fact that only 1,000 rows got moved in instead of 1 million. So you need both in those cases.
Ryan, Gabs asks, so the contract works as a gateway before sending the data from one tool to another. The contract API validates it? Question mark.
Yes.
Gabe actually asked. Gabe is from our team here, but this is a good open question. I think it'd be great to have people answer in the chat here. How are folks creating data quality checks today? Let us know in the chat. It'd be kind of an interesting conversation starter and point as well. We have a couple more questions to get through, so yeah, let us know in the chat. How are you guys creating data quality checks today? And then we will jump to the next question here. Jeremy asks, great talk, Chad. Don't you think the contract should look like a legal contract, but in Markdown with text and table?
I think in the ideal world, there would be some interface where you could translate some type of like Markdown system into like YAML or a protobuf file or something like that. In my experience, it's great to start these conversations as close to the developing team, the developer team, as you possibly can get. And so that just looks like, a repo in Git. And as long as you're speaking that language, I think it's great. One of the challenges, it sort of seems a bit contradictory, but one of the challenges with actually taking the simpler approach and sort of laying this all out in a document is that it's very intangible to a software engineer, right? It comes off as like a set of requirements. It has to be deliberated over for a very long period of time. It's like, what does this mean? What does that mean? But if it's all defined in Git, and you're connecting it to some actual object, like some set of a real schema, then it's much easier for them to see, oh, okay, we need a null value on this thing that I own. I totally get that. So yeah, I think at sort of a later maturity, having a really solid like definition system with Markdown and tables and all that stuff is probably ideal.
Great. Thanks for getting into details on that one. Tim asks, what was the administrative cost of adding those contracts, and what is projected for ongoing maintenance?
So I think it depends on what exactly you mean by administrative cost. If you mean by like what did it cost to build the infrastructure for that, it was non-trivial. So at Convoy, we have a data platform team, which I ran, and that was roughly 14 engineers all told, about half data engineers, half software engineers. And it took us, including strategy, brainstorming, all that stuff, about 6 months to put together sort of a really solid first version of a contracting system end to end. So there was that like engineering cost. There was also some costs in convincing the teams to take responsibility for those contracts. Although, admittedly, it was because I did a really bad job at selling it the first time. And I took the perspective of we all have, we should essentially take a data mesh style approach with domain-oriented design, and every engineer should own their domain. And that did not go over very well because it turns out that's a pretty tremendous amount of work to ask somebody to do. And so instead, when we switched to more of a incremental approach, as in a downstream consumer defines a single schema, maybe a few properties, a couple columns, like, as limited as I just want this one column to never be null, and I need someone to take accountability of that. And there's like a programmatic, very, very simple way of implementing this through an SDK or API or something else. Then the conversation actually got radically easier. And then in terms of the maintenance costs, most of the maintenance was not around the actual ownership. So, well, two parts. So there was the ownership of the infrastructure, which is like a separate thing, right? That's sort of an engineering problem. And then there was the ownership of the contract itself. It really depended on where the contracts were, what the maintenance cost was. For example, like some teams that were building relatively newly designed microservices, like they knew where all their data was. And, some engineer, like I was actually in meetings where a data scientist said, hey, like we need a contract on this data. And in 10 minutes, the engineer went out, put a contract on it. And then like during the meeting, they're like, okay, yeah, that's done. And that wasn't really a big issue moving forward. The places where it was a bit more challenging is when the system was like very legacy. So you have an older database, maybe the engineers themselves are not exactly sure how the code works. And so if someone says, I need this value to be a certain thing, and it changes unexpectedly, then they need to actually go out and figure out like what are all the possible root causes of this, which is why I recommend taking a very gradual, incremental ownership based approach. But overall, what we observed is that the engineering team actually started to accommodate these new use cases quite gracefully, and it wasn't a meaningful part of their on-call rotation.
Ujana asks, can you comment on data contracts' relationship to tech debt?
I can. By the way, I don't know if these are meant for me or if Brian, you want to take some of these. I don't want to just be a jerk and respond to anything.
No, you're good.
Okay. Yeah. So relationship to tech debt. So I think so. Again, like I think tech debt can have. You can point to tech debt at a few different locations. So there's the tech debt in the production systems or the databases, and there is a lot of tech debt there. At least tech debt from our perspective as people who care about like data and analytics and machine learning, because like these are oftentimes not representative of the world in the semantic context that we feel is most meaningful. They might change rapidly. There's just natural tech debt that accrues within microservices or monoliths over time that makes it very challenging to maintain or control. And then there's the tech debt within your data ecosystem, whether it's a lake or a warehouse or Snowflake or whatever. These are two like different types of tech debt, and contracts address them in different ways. In the first way, the way that it deals in the sort of database way, the way that it deals with the tech debt is kind of like by not dealing with it. Essentially, you create an abstraction, right? So, I mean, that's the whole function of an API. And you're essentially saying we should decouple our database from these analytics and ML use cases, put a layer of abstraction in the middle, and then tell the software engineer, hey, you no longer have to worry about what's going on the internals of your database, which like no one in the company should really be privy to anyways. And instead, just as long as you fulfill this contract, so as long as you vend the data in the way that the contract defines, like who cares? You can do whatever you want, and you can have whatever crazy tech debt is going on in your monolith or microservice. It doesn't matter. So that's how it sort of handles that. And then in the downstream use case for these like crazy queries that are spiraling out of control and spaghetti SQL and things that are 500, 1,000 lines long, the way that it tries to there's a couple ways it tries to get at that. The first way is that it actually almost necessitates ownership in a lot of cases. Someone, and we're sort of going into the weeds a little bit here, but one of the things that we've been in the process of rolling out is like when you get a contract request on a specific table, anyone who then tries to access that table or make some change to it has a choice. And the choice is I can establish myself as the owner of this if they are not already, at which point it is now my responsibility to either approve or reject the contract. Or I say, no, I don't have the ability. I'm not the owner, so I don't have the ability to modify this table. And they need to, fork it and essentially start, creating the data that they actually need and use, which is kind of a really happy coincidence because it leads towards data mesh, right? It's like teams breaking out the data that they actually own and are responsible for. So I think it definitely helps that. And then the last thing I'll say is when your contracts are all, we have found that contracts are also great for asking for new data. Like we have, we were doing this with events, not so much event. We didn't use a huge number of sort of like client side events, but we were using contracts to enforce server side events implemented in the same way, like protobufs and all of that. And so what a data person would do is say, hey, we've got this thing that happens in the real world called a shipment cancellation. We want that to be tied to a database change. Let's just go and emit an event like where this thing happens, because we don't have a great way of getting that data today. And if we get that and it's under contract, we can build a new, like, highly trustworthy data pipeline, and we can move off of all the old crap that we were leveraging before. And so we saw a lot of teams sort of using it for that purpose as well.
Yeah, actually, I'd like to backpack off of that because when we're talking about tech debt, one thing that we're doing is we're starting to tie data engineering practices with software engineering practices, right? And so whenever you have a tech debt scenario, the question is what's the trade-off for the benefit that you're getting for the thing that's incurring your tech debt? Pretty much everything's going to give you tech debt. No matter what you do, you're going to have tech debt. Now, that question becomes is, if you implement something that requires an enforcement process, your tech debt is not necessarily on the enforcement itself. Your tech debt is now on scaling the enforcement out and then what to do when something fails the enforcement. So that in and of itself is going to be tech debt. And then it's a matter of how do you automate both of those sides, and then how do you manage both of those sides, and then administration, and then hiring headcount to handle all of that. So it really depends on the tech debt orientation on what are you expecting your return on investment to be? What's your time to value with that? So that's a really big deal. And then the other thing that's important about tech debt is viewed as something that is kind of hindsight looking. No one looks in the future and is like, this thing will cause me this much hours of engineering backlog, and that's all my tech debt. So we need to do X, Y, and Z now, and then we'll avoid tech debt in the future. Sometimes you'll get that for someone who's seasoned, but most of the time you don't. So a lot of times it's actually hindsight looking. So my recommendation, anytime I talk to someone on the engineering side that's considering something like this or implementing anything new in general, the question is what's the low hanging fruit that you're going to get people to be really bought into, you're going to get them really excited about, and you're going to show that time to value is really short. When you do that, then they're naturally going to start building out solutions to at least kind of solve some of that tech debt before you even get there, because they'll already see that that's potentially going to be a problem. Well, if I'm going to need, I love data contracts, right? Like I love data contracts. Okay, how do I enforce a data contract? How do I scale new data contracts? Well, I'm going to automate that because I'm already thinking programmatically and engineering at the first set. So I'm already going to scale out that third set for us, right? So you got to be a little bit careful on that one. I would just say, like, look for low-hanging fruit, look for things that are going to provide value faster, things that people are bought into before you go after that. And then the tech debt will actually be a little bit easier to handle over time.
Great. Thanks for adding on to that, Brian. So I think we've hit over 15 minutes into this Q&A session here over the hour. Any other last minute questions? Now is your chance. Let me know. Otherwise, this has been a great conversation with both of you today. Thank you, Brian, and thank you, Chad, for showing up, preparing these slides, and educating all of us on this. There's going to be a recording available after the event that you can come to our page and see. We'll also be emailing that out to everyone. And go to Chad's page to check out his other material. He posts often on this type of material. He also has a wonderful Slack community, Data Quality Camp, that you can check out and join that to continue the conversation over there with him. And if you're interested in learning more about enforcing data contracts with a monitoring solution like LightUp, there should be a link in the chat here that Michael Pickens sent out. If not, we'll also be sending out that link in an email after this event. You're always welcome to Google LightUp to learn more as well. So yeah, with that, thank you all. Have a good rest of your day, and we'll see you at the next event. Take care.
Thanks, everybody.